In this video, we're going to take a look at the quotient rule and basically see how it works. So the quotient rule you can basically is basically used for when you've got a function like this, where you've got some sort of a fraction like this, where you've got a function at the top and at the bottom, and neither of these are constants. So the formula, and there is going to be a formula that we're going to be looking at here. The formula here for the derivative of this function is going to be as follows. It's going to be relatively similar to how we use the product rule, but it's just a little bit different in the details of it. So you've got the derivative of u of x, which we call u dash, times the original function v of x, minus u of x times v dash of x. And we're going to take this and take all of this stuff here, and we're going to divide it by v of x all squared. And so this is the actual formula to find the derivative of our original function of x. Now we're going to do an example so that I can show you just how this works in practice. And the function that we're going to be looking at is this one here. We're going to have some example here. The function we're looking at is some function f of x equals to 3x minus 1 all over x squared plus 4. And you can see that in this case here, it's not quite so simple to rewrite it as a single fraction. So that's why the quotient rule here becomes quite handy. So what is my u function and my v function? Well, my u function, u of x, is going to be, well, whatever's at the top here. So that's 3x minus 1. And my v function, v of x, is going to be x squared plus 4. Now, how does the formula help us? Well, we need to find the derivative of u of x, and we need to find the derivative of v of x. So that's why over here I'm also going to write my derivative of this function, u dash of x, which you can see here, well, the derivative of all of this function here is just going to be 3. And the derivative of all of this function, v dash of x, is just going to be what? Well, that's just going to be 2x, isn't it? Cool. So far, so good. Now we have all the information to plug in all of our values over here. So you can see here we've got u dash of x, that was 3. So let's go ahead and start writing down what we have found. So u dash of x is equal to 3. And we're taking 3 times our original function v of x, which was, if you recall, x squared plus 4. So 3 times x squared plus 4. Then minus our original function u of x, which was 3x minus 1, times our derivative v dash of x. So that's times 2x, like that. Okay. And then we're taking all of this stuff here, and we're dividing that by v of x squared. So if you recall, again, that was x squared plus 4 all squared. And again, from here, we're basically done with the example. It just looks a little bit messy, so we're going to tidy this up a little bit. So this becomes, if we expand it, becomes 3x squared plus 12 minus, we've got 2x times 3x, so minus 6x squared. Then we've got minus negative 1 times 2x, so that just becomes plus 2x. All divided by x squared plus 4 all squared. Well, we can simplify this a little bit further, just to make it a little bit more tidy. So this becomes 3x squared minus 6x squared. Well, that becomes negative 3x squared. Then we don't have any other singular x terms in here, so that just becomes plus 2x. And then finally, we just have plus 12 at the end, all divided by x squared plus 4 all squared. And we're done. This is the derivative of this function over here.